Vermont's tallest mountains, like Mount Mansfield and Camel's Hump, might draw tourists, but they're not the first places you'd call biodiversity hotspots. High elevations in Vermont are cold, wet, and rugged. Above 800 meters, hardy conifers are the only trees which can survive. This habitat may not look impressive, perhaps, but these are some of the only living remnants of the last ice age. In comparison, Vermont's temperate lowlands seem to teem with life. Rich forests, wetlands, and prairies brimming with flowering plants. Generally, biodiversity decreases with altitude or peaks at medium altitude. But nature loves exceptions, and the best known exception to this rule is parasitoid wasps. Parasitoids are a subgenre of parasites that inevitably kill their hosts. Parasitoid wasps lay their eggs inside or on a staggering variety of arthropods, mostly other insects and spiders, but their diversity has not been observed to consistently track the diversity of those other arthropods, or any other environmental factor for that matter. For the past 5 years, I've studied the diversity of wasps across Vermont's elevation gradients. My results once again corroborated the anomaly. I found that parasitoid wasp richness was highest at both the lowest and highest elevations, a very rare pattern and a stark contrast to pollinating and predatory wasps, which decreased in richness rapidly with elevation. So why were parasitoids so rich at high altitudes? It's not just about what hosts they target. Parasitoids and predators alike often overlap in their host preferences. It may be about energy efficiency. Predatory wasps are like gas-guzzling tanks, large and energy-intensive in that they must consume a handful to dozens of prey to mature to adulthood, at which point they must frequently carbo-load on flower nectar to maintain their metabolism. Parasitoid wasps, by comparison, are more like subcompact hybrids, as small as they come and highly efficient in that they're able to complete their life cycle with just one host, sometimes producing multiple offspring from a single host. My research in Vermont found that body size was the key factor influencing wasp family richness patterns across elevation. Large-bodied wasp families, including large parasitoids, were limited to warm, resource-rich habitats because they require more biomass, while smaller wasps thrive even in the cold where resources are scarce. In addition to being a window looking back at the last ice age, Vermont's alpine tundra supports a surprising diversity of parasitoid wasps. As temperatures continue to rise globally, lower elevation communities are moving upslope. But tundra specialists are running out of mountain decline. The conservation of these vitally important insects is my main motivation for continuing to do and share this research.